Okay, so this is number 13 from your review, and all we're going to try and do here is keep track of a few different transformations individually so that they're not mixed in. Okay, so we're kind of just trying to do some individual work here. Okay, so what I've done for each of these is I've graphed, there'd be 6 questions. I suppose there are 4 questions. Maybe I didn't need all 6 graphs, but you'll see the base graph will be on each grid. So I guess the first part of A is already done and the first part of B is already done. We've graphed the base. Okay, so what these are asking us to do is transform them. Okay, so A is going to be the base, so f of x, and then g of x. G of x is going to be the transformed graph 1/2 x squared. Okay, now I see brackets for this graph, the g of x. Okay, sorry, the g of x function. Okay, that implies, I'm just going to a g of x. What I'm going to do is just write down the transformation here, right? This is saying, because it's on the inside, and I'm seeing that it's a fraction, one might think it's a horizontal compression. Okay, but remember, anytime you write this word horizontal initially, you're going to do opposite, opposite, opposite. Anytime you write that down, it's opposite, right? So it's a horizontal stretch by a factor of not 1/2, of 2. Okay, so we're going to go over here. What we're going to do is we're going to horizontally stretch the base graph of y equals x squared, right? And we're going to get the new g of x function, right? So horizontally stretching by a factor of 2, that goes to there. And then if we're 2 away, it's going to go to 4. Okay, 0 stays at 0, 1 goes to 2, 2 goes to 4. Okay, and so essentially what you can see is we've taken our base graph. Oh boy. That's not going to do it. We've taken our base graph and we have made it wider by horizontally stretching it. Okay, so there is your g of x function, which would be equal 1/2 x squared. Okay, now h of x has 2 transformations on it. The first one is a vertical reflection, okay, over the x-axis. Okay, and the second transformation that I see, again, it's on the inside, so I'm going to write down the word horizontal because it's on the inside. Okay, and it's always opposite. Okay, and so it's a horizontal compression this time by a factor of 1/2. Okay, so for h of x, this graph here, the base graph, is just going to get reflected vertically and then as well as compressed by a factor 1/2 horizontally, right? So we're going to flip it or reflect it, and then it will get compressed horizontally, which I'm just going to do. I think we can handle probably doing this in one step. Okay, this point is 4 away here, so it's going to go to 4 away here, but then I have to cut it in half, right, horizontally, so it's going to go to there. Okay, so there is your new graph there. That will be h of x. Okay, sorry, maybe not the best layout here. H of x is going to equal negative 2x squared. Okay, that takes care of question A. Question B is dealing with a different function. Okay, so we kind of get a little break here. I've graphed the original. Okay, it's the absolute value graph, which has the appearance of a v. And what we're going to do is transform it, right? So in B, g of x, if I come down here, B, g of x says there's 2 transformations. There is a everything's on the inside of the function, right? You can see here the absolute value bars are the same thing as brackets for the most part. Okay, they're signifying the inside of the function. I see that there's a negative and a 4, so the negative on the inside means that there's a horizontal reflection over the y-axis this time. Okay, and then so that'd be one transformation, and the second one would be, sorry, there we go. The second one would be again, you're writing the word horizontal because it's on the inside. Horizontal compression. Compression by a factor of 1/4. Okay, so if I go down here, what I'm going to do is reflect this graph horizontally. What's interesting about a graph like the absolute value graph, or the quadratic for that matter, the graph is actually symmetrical about the y-axis. So when I reflect that graph, this point comes over here and this one comes over here, I get the same graph back. So a horizontal reflection for an absolute value graph doesn't actually change it. Okay, so all we have to do for this is just cut those values in the quarter, right? Like, so if we are at 0 is going to stay at 0, 1 is going to get horizontally compressed by a factor of 4. That's going to go to there. Okay, very close to the axis. That's going to get very close to the axis as well. And then 1/4 of 2 is going to be 0.5. So this graph essentially gets very, very skinny because I've taken it and I've pushed on it horizontally by a factor of 1/4, right? Or I cut the x values into quarter of their distance away from the y-axis. Okay, so that's going to be your graph. G of x is equal to negative 4x. Okay, now we got one more to do here. It'll be the h of x function. The h of x function, okay, I see a 1/4 on the inside. Inside is the key word there. That's signifying horizontal versus vertical again. And there's only one thing. So it's a horizontal stretch now by a factor of 4. Okay, so I'm going to take the base graph, and h of x, I'm going to horizontally stretch it by a factor of 4. Okay, so this one is a distance of 1 away from the y-axis, which 1 is now going to go to 4. 2 is going to go to 8. So 2, 3, 4, 5, 6, 7, 8. Okay, 0 is going to stay at 0. 1 goes to 4. And 2 is going to go to 8. Okay, sorry, miscounting. 2, 3, 4, 5, 6, 7, 8. There we go. Okay, so there is your h of x function. Okay, that'd be h of x is equal to 1/4 the absolute value. Okay, so that's that.